One thing that we end up doing a lot in both science and math is making an estimate and then comparing our estimate to the actual value of something. And it's helpful to know, was our estimate even close in the first place? And how close it was is a little bit of a difficult thing to determine sometimes. And so we're going to use a process called percent error to answer the question, how far off was our estimate from an actual value? So first, let's do a little bit of estimating. Below are two quantities in weight. What I'd like you to do first is to pause this presentation for a minute and in your notes, write down your best estimate of Mrs. Devers' weight. You can use pounds for this because pounds is a unit of weight that we're familiar with. And don't worry, I won't be offended. Then I'd like you to estimate the weight of your science binder. Again, you can use pounds for this. And don't worry if it's not exactly right. We'll be fine. Okay, so now you should have some estimates of Mrs. Devers' weight and your binder's weight. Let me tell you now the actual values for these. As of today, Mrs. Devers' actual weight was 138 pounds. And a typical science binder weighs approximately 1 pound. So it's likely that your estimates were not exactly the same as these actual values. And so a reasonable question to ask is, which was a better guess? Take a look at how far off you were from estimating Mrs. Devers' weight and how far off you were from estimating the weight of your binder. And pause this presentation for a minute while you write down in your notes which of your guesses you think was a better guess and why. So what you may have noticed is that you might have been off by, let's say you were off by 5 pounds on Mrs. Devers' weight. You thought Mrs. Devers' weight was 143 pounds. You guessed a little bit high. But really, 5 pounds out of a total of 138, that's not very far off. If you were off by 5 pounds guessing the weight of your binder, you might guess that your binder actually weighs 6 pounds. That means that your guess was off. You thought it was 6 times heavier than it actually was. That's a lot off. So the same absolute amount of being incorrect, that 5 pounds that you were off, seems like a really bad guess for the weight of your binder and a pretty close guess for Mrs. Devers' weight. Why is this? Well, we're going to look at the calculations for percent error to help us. First off, let's define what percent error is. Percent error shows how close your guess was relative to the thing you were measuring. And that phrase relative to, that means like compared to the thing you were measuring. There's a formula for percent error, and it looks like this. We're going to take the estimate that you made and subtract off the actual value. So you would take the estimate of Mrs. Devers' weight minus her actual weight. And then we're going to divide that by the actual value. So we make a ratio. A ratio is a way of comparing two things. And on the top is the difference between your estimate and the actual. That's a measure of how close you were. And on the bottom is the actual value. So we compare it to the thing you're measuring. Estimate minus actual on the top and actual on the bottom. That's going to give us a fairly small fraction, and to turn that into a percent, we need to multiply by 100. The smaller the percent error is, the closer your estimate was relative to the thing that you're measuring. So let's go through some examples. This will be a little bit easier to understand this formula if we can see it in action. Notice that we sometimes are going to get a negative percent error, and that just means that our guess was too low. Okay, so let's come back to our examples. I'd like you to calculate the percent error of your guess of Mrs. Devers' weight. So here's what you're going to do. First, we're going to write the whole formula for percent error. It's estimate minus actual, all of that over actual, times 100. Now, what I'd like you to do is to plug in your estimate in the blank that's shown here. So whatever you guessed, whether it was 130 or 150 or 200 or whatever it was, it goes in the blank in this equation here. And I filled in for you that the actual weight both on the top and the bottom in this ratio should be 138. We're going to take whatever answer we get when we make that ratio and multiply it by 100. So that difference, your estimate minus actual, goes on top of 138. Do that division and multiply it by 100. To help you understand whether or not you did the math right, I'm going to walk you through this calculation with a guess. So imagine that I had estimated my weight at 135 pounds. So when I do this calculation, I would be filling in that blank with 135 pounds. 135 minus 138 is going to give me negative 3 on the top of that fraction. So I'll have negative 3 over 138 times 100. When I do negative 3 over 138, that's a division problem. That's negative 3 divided by 138. I get negative 0.0217. And when I multiply that by 100 to turn it into a percent, I get negative 2.17%. The number that you have should be somewhere close to this. If you got a number that was far, far off, let's go back and check your arithmetic. Next, let's repeat this process with the weight of your binder. Again, we'll start with our formula for percent error. And a typical binder weighs about a pound. So we'll set up the formula and we'll replace the actual weight with 1 pound in both the numerator and denominator of this fraction. And you'll fill in the blank here with whatever your estimate for the weight of your binder was. And then you'll simplify the numerator of that fraction, and you'll multiply your answer by 100. Again, it'll help if I go through this with an example that has some numbers for you. Suppose that you estimated your binder weighed 1.5 pounds, or 1.5 pounds. So you would fill in the estimate with 1.5. Well, 1.5 minus 1 is simply 0.5, so the next step in my calculation is 0.5 over 1 times 100. 0.5 over 1 is just 0.5, and when I multiply that by 100, I get 50%. So I was off by 1/2 pound on the weight of the binder, but that's a 50% error. On Mrs. Devers' weight, I was off by 3 pounds, but it's only a negative 2.17% error. You can see that even though I was off by 3 pounds on Mrs. Devers' weight, my estimate was really a much better estimate than my 1.5 pounds estimate for the weight of the binder, because the percent error number was much smaller. This is the end of this lesson on percent error. Next time, we're going to go through your notes and see what things can make them even better.